Hope you guys watched the previous video. So we are now continuing with the problems related to Coulomb's law. And the next question it is uh, suppose the spheres A and B in example 9 have identical sizes. A third sphere of the same size but uncharged is brought in contact with the first, then brought in contact with the second, and finally removed from both. What is the new force of repulsion between A and B? So the example 9 is here, and here there are two copper spheres A and B, and their charge is given. They are having the same charge and separated by a distance of 50 centimeter. So this is the question, or this is the situation we need here. And have identical size, a third sphere here, a third sphere but uncharged is brought in contact with the first. So there were initially two spheres A and B having the same charge. Maybe I am taking the charge as Q. Okay, and here the change is a third sphere of the same size but uncharged. So uncharged one is brought in contact with the first, okay, and then brought in contact with the second. That's the question here. So at first the C, let another third sphere be C, and C is brought in contact with the first one, that is A. Now the here it is given that the third sphere is having the same size as that of the others. So the charge will the total charge will be distributed equally to both of them. So the A will get the charge Q by 2, that is Q plus 0 by 2. The charge of the C is 0, and C will get the charge Q by 2. And in this next situation, this C or this C is brought in contact with the B. So C is now having a charge Q by 2, right? And this Q by 2 charge is brought in contact with the B, and B is having Q. So now that equal distribution takes place. Total charge here is Q plus Q by 2, and the whole divided by 2. That will be 3Q by 2 divided by 2, that will be equal to 3Q by 4. So 3Q by 4. So now C and B both have 3Q by 4. Okay, and that's also A now have Q by 2 charge, and B have 3Q by 4 charge. Okay, and they are at the same distance as that of the previous, that is 50 centimeter away. And here the question is, what is the new force of repulsion between A and B? What is the new force of repulsion between A and B? We can find it simply by applying the equation, that is 1 by 4 pi epsilon 0 3Q by 4 multiplied by Q by 2 all divided by R square. That will be equal to we get it as 3 by 8 into 1 by 4 pi epsilon 0 Q square by R square. That will be equal to, we have found this answer in the previous question, or this calculation in the previous question. So the answer was 3 by 8 multiplied by 1.5 into 10 raised to minus 2. So final we will get as 0.5625 multiplied by 10 raised to minus 2. So by rounding off, and we will get the answer as 5.7 multiplied by 10 raised to minus 3 Newton. So this was the answer to this question, and we are moving to the next question, that is mm, two similarly equally charged identical metal spheres A and B repel each other with a force of 2.0 in 10 raised to minus 5 Newton, and a third identical uncharged sphere C is attached to A, then placed at the midpoint between A and B. Calculate the net electrostatic force on C. Nice question. It is here. I think this question must be skipped because I have already done this question in another video. So maybe watch that video on electric charges. Okay. And now moving to the next question. Two identical charges Q each are kept of a distance r from each other. A third charge q is placed on the line joining the above two charges such that all the three charges are in equilibrium. What is the magnitude, sign, and position of the charge q? So that's the question. Two identical charges, that is q. Two identical charges q, and each are kept at a distance r. Q and Q are kept at a distance of r, and a third charge q is placed on the line joining the above two charges, that all three charges are in equilibrium. So that third charge is it will be placed in the middle of that two charges. So it is like this, and the distance between them was r. So let this q be x distance apart, distance from the q, x. Okay, and here what is the magnitude, sign and position of the charge if the charges are in equilibrium? That is the question, that is the thing to be noted. They are in equilibrium. So what is the magnitude, sign, and position of the charge? So for here, third charge q, the force q will be in equilibrium if and only if the force applied on it by this q, or the charge q in the left side, must be equal to the force applied by the q charge in the right side, and that must be also opposite to the that is the middle one. Okay, that is q. So we can find now, equate the forces between them. Okay, the force between the left one and the right one, that is from okay, leave that. And so by equating, we will get it as k q q, k q q by, that is a force between this capital Q and small q. So k q q divided by x square, distance is x square, must be equal to k q q between the right one and the middle one. I don't know, listen on the middle, I'm just saying, I mean in between them, and k q q divided by r minus x the whole square, r minus x the whole square. And so here we will get that x square must be equal to r minus x the whole square, r minus x the whole square. That means x equal to r minus x, x equal to r minus x. So the position of the x must be equal to, that is here when the minus x is taken here, 2x equal to r, so x must be equal to r by 2. So that was correct, that I have said that it is in the middle. Yes, the distance x is r by 2, r by 2. The force of repulsion between charges at A, that this be A, and this be B, and this position be C. Okay, since the charge at A is repelled by let the position of this left one be A, and the middle one, that it will be B, and of the right one C. Then, and since the charge at A is repelled by the similar charge at C, so it will be in equilibrium if it is attracted by the charge Q at B. That is, the sign of the charge Q should be opposite to that of the charge Q. Therefore, the force of attraction, or sorry, the force of repulsion between A and B, between A and B, A and B. Oh, sorry, force of repulsion between A and C. Okay, force of repulsion between A and C must be equal to force of attraction. Force of attraction, attraction between A and B, because they are opposite charges. Okay, the attraction between A and B, between A and B, okay. And so we can do that calculation, that is K Q divided by R by 2 the whole square. K between A and C, that is sorry, okay, K Q divided by R square, both are same, okay, and it must be equal to K Q by R by 2 the whole square, K Q by R square must be equal to K Q by R by 2 the whole square. So here it must be capital Q, okay, I forgot, because it is between the A and C, that is both are the same charges, that is Q or Q square by R square, okay. And now we get Q as the Q by 4, capital Q by 4. So we got the value of Q and also the position of Q, and the sign must be opposite to that of the capital Q. We don't know what is the sign of the Q. It is not mentioned in the question, okay. So moving to the next question. So it is a question, 2 point charges plus 4e and plus e are fixed a distance apart. Where should a third point charge Q be placed on the line joining the two charges so that it may be in equilibrium, and in which case the equilibrium will be stable and in which unstable, okay. That's the question. So we are going to do that. 2 point charges plus 4e and plus e placed like this and fixed a distance apart, okay. The distance is a, and the third point charge Q is placed on the line joining the two charges. So it may be placed here, and it is a positive charge, right? Yes, it is a positive charge. So a positive charge is placed in between the line joining them, like this. So I am taking the distance between this E and plus Q as or this 4e and plus Q as x. Then the distance between plus Q and E will be a minus x, okay, a minus x. So for the equilibrium of the charge plus Q, we must have force of repulsion F1, let it be F1 between plus 4e and plus Q must be equal to the force of repulsion F2, that is between plus E and plus Q. That is, we can write it as 1 by 4 pi epsilon 0. You know, what I am saying is that the force of repulsion between plus 4e and plus Q, for the plus Q to be in equilibrium, that is the force of repulsion between plus 4e and plus Q, that is acting towards this and this direction, and the force of attraction between plus q and plus c, that is in the opposite direction. So they must be equal in order to plus q be in equilibrium. So we are writing it, that is 1 by 4 by epsilon 0 into 4e multiplied by q divided by x square. The distance between 4e and q is x, so x square must be equal to 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0 e and q, e q divided by the distance is a minus x, so a minus x the whole square, a minus x the whole square, a minus x the whole square. Okay, and now doing calculation, e gets cancelled, 1 by 4 everything gets cancelled, so 4 into a minus x the whole square, 4 into a minus x the whole square must be equal to x square, So taking the root on each side, that is we get 2 multiplied by a minus x is equal to plus or minus x. Okay, and now we get x as is 2a minus 2x equal to plus c, or 2a minus 2x equal to minus x. So we get by calculation x equal to 2a by 3, 2a by 3 or 2a, 2a. 2a by 3 or 2a, it is 2a. Okay, I'm using a mouse, so it is difficult. I have no graphic tablets. And now what is that? We have found two positions, so which is the position we need to take here? It is said that the plus q charge is placed in between them. Okay, so they to be in between those two charges, the position must be 2a by 3. So we got one answer, and here is another question too, in which case the equilibrium will be stable and in which unstable. So we have considered the charge plus q to be positive. If we displace it slightly towards the charge E from the equilibrium position, then F1 will decrease and F2 will increase, and a net force F2 minus F1 will act on Q towards left, that is towards the equilibrium position. Okay, hence the equilibrium of positive Q is stable. Now if we take the charge Q to be negative, the forces F1 and F2 will be attractive, and the charge minus Q will still be in equilibrium at x equal to a by 3. And however, if we displace charge minus Q slightly towards right, then F1 will decrease and F2 will increase. A net force F2 minus F1 will act on minus Q towards right, that is away from the equilibrium position. So the equilibrium of the negative Q will be unstable. So equilibrium of the negative charge, if it was negative, then it will be unstable, otherwise it is stable. And moving to the next question, two free point charges plus 4e and plus e are placed at a distance apart. Where it is, isn't it the same question? Oh no, I placed it between them. I mean, where should a third point charge Q be placed between them such that the entire system may be in equilibrium? And what should be the magnitude and sign of Q? What type of equilibrium will it be? Here, the system should be in equilibrium. In this question, the system should be in equilibrium. That's the change between the previous one and this. So how can we do this? Suppose the charges are placed as shown in this figure I am making here, that is plus 4e and plus e, and a charge is placed in between them, that is I am writing the q. So the where should a third point charge q be placed, that's then such that the entire system may be in equilibrium. The entire system must be in equilibrium, right? So as the charge plus E exerts a force F on plus 4E. So for the equilibrium of the charge plus 4E, the charge minus Q, a minus Q must be, minus charge must be placed here. So that repulsion, the repulsive force must be in this direction. So in order to cope up with that, an attractive force must be in the opposite direction. So this minus Q charge must be negative, or this charge placed here must be negative. Okay, and so let the distance between this plus 4e and minus q be x, and the total distance be a. Okay, it is given. Take a, and this will be a minus x, and now we have to do the calculations for the equilibrium of plus 4e. Okay, plus 4e, the force F, that is the F between this be the F, that is repulsion between plus 4e and plus C, that must be equal to the attractive force between plus 4e and minus C, that let that attractive force be F dash. Okay, so F must be equal to F dash. So we can do the calculation, that is 1 by 4 pi epsilon 0, 4e and e, 4e multiplied by e divided by distance is a. Okay, so a square must be equal to 1 by 4 pi epsilon 0, and 4e and q, 4e multiplied by q divided by the distance is x square. So here we can do, we will get the what is that, oh sorry, is here. So we get q as ex square, the whole divided by a square. So we got q ex square by a square, but this is still unknown because x we don't know what is the position, so we have to find the x. And now for the equilibrium of the minus q charge, the attraction between plus 4e and minus q must be equal to the attraction between minus q and plus c plus e. Okay, that is let this force, the attraction between plus 4e and minus q be F1, and the attraction between plus e and minus q be F2. So F1 must be equal to F2, right? So we can equate that and find out that exact value of q. So that will be 4 pi epsilon 1 by 4 pi epsilon 0 into 4e into q divided by distance is x square equal to 1 by 4 pi epsilon 0 into e into q divided by the a minus x square. This is a. Okay, a minus x square. And so here by doing okay, now we get here x square equal to 4 into a minus x the whole square, okay, and now x will be equal to 2a by 3. That's all. So we can apply that value of x in the this equation we got. So q will be equal to, we know that we got ex square by a square. Now applying x, the value of x here, so e by a square, this is e, okay, e by a square multiplied by the square, that is squaring this, 4a square divided by 4a square divided by 9, 4a square divided by 9, that will be, we get 4e by 9, 4e by 9. So the value of q is 4e by 9. The equilibrium of the negative charge q will be unstable. Okay, we have discussed that earlier in the previous question also. So now moving to the next question. So, 2 point charges of charge values plus q plus capital Q and q are placed at distances x and x by 2 respectively from a third charge of charge value for q, all charges being in the same straight line. Calculate the magnitude and nature of the charge q such that the net force experienced by the charge q is 0. So the charges are placed like this at the position A. Let there be plus 4q charge, and at the position B there be the charge capital Q, which is x distance apart from distance from the plus 4q charge. Okay, so this be the capital Q, that is x distance apart, x, and let C be the place where small q charge is placed, and that will be x by 2 distance apart, x by 2, this is in the middle. Okay, so this is the figure we need to know. And now for the equilibrium of the charge q, that is plus q, small q, the charge q must have the same, the q must have the same sign as that of the q, that of the small q, and plus 4 small q, so that the forces Fa, that is Fa and Fb are equal and opposite. Okay, that is, if the q is positive, then this all these charges must be positive, so the repulsive force will be like this, F1 and F2. This is the force. Okay, leave that. And now we can equate that Fa and Fb, Fa equal to Fb, that is, we get 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0, 4q multiplied by q divided by, this between 4 this 4q and this q, and 4q multiplied by 4q divided by x by 2 the whole square, x by 2 the whole square, and that must be equal to 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0 into q into q divided by x by 2 the whole square, x by 2 the whole square. Okay, and so we get x by 2 cancels out, so we get the capital Q as 4q itself, so both of them were the same charge. So I think I have completed those questions I have taken from the topic Coulomb's law. So thank you, and to know more about the cloud vendor, visit our website. You can Google by typing cloud vendor Gaurish. Site appears as the first result, and or simply search cloud vendor and you will get the site as the third result. And also you can follow us on different social media platforms, and You can follow us on Instagram, and you can follow on WhatsApp. I have created a WhatsApp group for discussions on different doubts you have, and the links are given in the description box. Also, a Telegram group for discussion and the same purpose, and a channel is also formed for giving off your learning steps, and all the links are given in the description box. You can check it later. You can also ask your doubts as comments in YouTube, and if you want more videos which would be uploaded in the coming days, please subscribe our channel and press that bell icon for getting notifications on time.
Hope you guys understood the topic. Thanks for watching my video. Always be free to ask questions. Subscribe to my channel for more videos. If you like this video, share it with your friends. See you guys.